Good morning, and thank you for being here with us today at our 2021 Beyond Big Data virtual event. If you have questions at any time, please feel free to send me or Tom a message in the chat, and we will get them as needed. We're going to jump right into breakout number 1, Analog Machine Learning, Reduce Big Data at the Source, and I'm so pleased to welcome our presenter for this session. We have with us today Tom Doyle, founder and CEO of Aspinity. Tom, thanks for being with us on this Monday morning. The virtual stage is all yours.
Well, thank you very much, and definitely appreciate it. A little bit about us. So Aspinity is a deep tech startup based in Pittsburgh, a well-funded startup with regards to new technology that we're bringing to market. And so I want to talk to you about it. When we think about big data, we think about beyond big data. It's all about data processing, and we think of that in terms of just the sheer growth in the number of sensors and pieces of and products that are gathering information so that we can make decisions. And we're just seeing an explosion in that. And I'll talk a little bit about that and our technology and what we're bringing to the market and why analog machine learning is really going to be important over the next coming decades with regards to how we process data. So when we think about all the data, and we think about the number of devices that are out there gathering data, and that there's just going to be extreme growth with regards to those devices. We're seeing about 42 billion connected devices that are generating 80 zettabytes of data. Now that's great, but when we think about this particular sector and what we're doing in this industry, some of the fastest growing segments are what we call always on and battery operated devices. So think about things like like the earpods that we wear, or think about wearable technology that's picking up voice for transcription or for communication that are on the body that have to be operated with batteries. We think about TV remotes, right, for entertainment purposes, but we also think about machines in the factory that could go bad, and we want to constantly monitor their health to make sure that we know when something's going bad so we can deal with that in an efficient manner. Some of the key challenges, though, with regards to these always-on and battery-operated sensors is the fact that they're really challenged from a power perspective because they're processing a lot of data. And we've seen a movement of data processing from the cloud down to what we now call the edge, which is localized. And there's a lot of data that has to be analyzed and processed simply because you can't take all of that data and push it to the cloud anymore. The sheer number and growth of devices is causing that to be a problem. But there's another challenge too, and it's privacy, and it's keeping data localized or local to the sensed area as well. Sorry about that. So we address that privacy by moving more and more processing to the edge, and that's what the industry is driving for as well. But even when we look at these edge architectures that we have today, they're very inefficient. So the majority of 70 to 90% of the battery life is actually wasted at the edge processing data that's really not relevant or doesn't tell us anything that we're looking for. So when we think about that, that could be up to about 50 zettabytes of that data, of that processed information is just wasted. And that really has a real big impact on the battery life for these always-on devices. And so we look at that, and that's kind of where Aspinity and our analog machine learning is really targeting this next generation, this explosive growth of these devices that are battery operated, but gathering data all the time. The fundamental issue is this boundary between what we call the analog world, the real world, and the digital world. So the little known thing that most people need to recognize is the fact that all of the data that we analyze is naturally analog. So if you think about sound data, all the sound data in the room that these devices pick up is messy. It's unstructured analog data. One of the best things to look at is an EKG chart where you see all the squiggly lines. That is very much unstructured unstructured analog data. But what we do is we need to analyze that in the cloud or even in some of our devices such as microcontrollers and microprocessors. Those are all digital. And so that's what we look at. How can we do more in the analog world? So from our perspective, analog is very critical for this digital future. Digital components just can't consume too much power to process all the data in an always-on device. Now, let me give you some examples and some numbers. Typically, a CPU or an MCU will consume about, in the tens of milliamps of power. Now, that's just too much to be operated on a couple AA batteries for a long time. That's why our earbuds don't last so long. It's very small battery. That's why a lot of these devices do not last a long time. They consume too much power, always looking at the data. Analog addresses this because, as we talked about, the sense data is all naturally analog, but also analog is extremely low power. And in many cases, it can be formed, it can perform analysis and some of the functions more accurately and efficiently than digital solutions as well. And this is exactly where Aspinity is. We're pioneering this new disruptive analog technology that's really revolutionized how we look at power and data efficiency at the edge for these always-on devices. So we call it an analog machine learning core. It's based on our RAMP technology, a reconfigurable analog mixed signal processor. It is a chip, and it's called our AnalogML core chip. And it really does combine a few different technologies. Number one, we're a neuromorphic computing device. So neuromorphic is based in emulating the efficiency of the brain and the sensory system and how we process data. I mean, as an example, as I'm speaking, I can hear outside noises and whatnot, but my focus, the brain is very good at this. My focus is on talking and speaking at this conference and acknowledging, but ignoring those other sounds that may or may not affect me. We also combine machine learning capabilities. Typically, people are thinking machine learning is neural networks and AI and whatnot, and it's doing inferencing and classification. And we do that the same as what's done in the digital world, but we host this on analog and purely analog technology, which is very challenging, but the benefits far outweigh those challenges, and we're really addressing those challenges as well. And so what we're able to do with our core is actually look at that raw, unstructured analog data in its natural form, make inferencing or detect events or anomalies, and then wake up a higher order system, a higher power system for the next stage. And eventually that data gets to the cloud. But by the time it gets to the cloud, it's actually relevant information to what we're trying to improve. So you can think about this as applicable in many different applications. Voice is a prime one. I'll talk a lot about voice because it's just such a new and an innovative way to communicate and gather information, but it's challenged as well. But acoustic event detection, vibration anomaly detection, heart rate anomaly detection, and more as well. And so we really stand alone as a low power machine learning chip that enables the entire system to be really low power, which really extends that battery operation as well. It's pretty straightforward with regards to, I'll talk a little bit about where we are today. And this kind of describes that particular process of, in the traditional solutions, as we talked about, you'll see in the background some messy signals where the sensor data is gathering that analog information. We automatically digitize that and look at it in a digital processor only to find out that the data is irrelevant. And I'll give you an example about that down the road, but there's a lot of power consumed in digitizing, moving this from these difficult signals to zeros and ones, if you will. And so there's a lot of power consumed, especially if you're always on, and really too much to be able to be compatible with longevity on batteries. And so when we think about, what we do, we add a new core into the system where we intercept that data. We look at that data at really low power levels. We're talking 10 microamps of power to detect speech, much different from milliamps of power. And when we detect something of relevancy, we wake up the rest of the system, and the data gets digitized and looked at further inside of a digital system and sent to the cloud as well. And so in the end, we just see upwards of 10 times improvement in battery life for these voice devices, but even more for other acoustic events and things of that nature. Voice is just such a prime example, and I'll kind of explain it in a really easy way to understand. When you have a device that you're wearing or even your device that's plugged in at home, you have to know that all of that sound data in the home is being processed. It's being digitized and processed. And the main thing that they're looking for is the wake word, right? I don't want to say too many wake words. I'll key everybody's systems, but the one that begins with an A or hey. And so what happens is you're processing all that sound as if that wake word is going to come at any time, which it can. But what we do know is that up to 80, 90% of the time, there's actually no speech whatsoever. But these devices process it as if non-speech is going to have a wake word, which it won't. And so what we're able to do in these systems is for the 10 to 20% of the time, we'll wake up the system that's running a lot more power, and then they can look for the wake word or commands or whatnot. And so by doing that, we're actually shutting the system down, keeping data localized, right, before it gets processed, and saving a lot of battery power as well. And so that's very important with regards to saving battery, but also that security issue that I mentioned as well. So when you think about what we're doing, I mean, inside of our core, it's pretty interesting technology in the sense that we're actually constantly processing all of this data, and we detect speech, or we detect other events as well, and then we provide that information for feature extraction and compression, and then when we wake up the system, everything moves ahead quite nicely. And so it's similar technology to what you'll find in the digital world, but we host it on really, really low power hardware. And so we do the sensor interfacing, we do the feature extraction, the compression, we have a neural network that helps make decisions, and then we send a wake up trigger to the rest of the system. And by doing that at really, really low powers, and that always on power is reduced really down into the microamp range. When we look at it from the real benefits of the voice system, is kind of another way to look at things. Our AnalogML core is more of a sentinel, if you will. It's always processing all of that raw information. And you'll notice at the top that we shut off the rest of the system. But down below, the battery gets drained very quickly because it's processing all the sounds, the dog bark, the telephone ring, as if there could be a wake word there, or there's a command there, and there's actually no voice whatsoever. And so really we're able to maximize both the number of the components in sleep mode and the amount of system sleep time as well. And so, we don't miss any data whatsoever. So these are applications that really are predicated upon, gathering all of this information and processing it, not missing it. I will tell you, if you miss any, you can't duty cycle the system below, in the sense that the reason being, if you miss any part of any commands or wake words, the whole system is now not accurate. And so that's why it's very important from that perspective. So when we look at what we are doing, I want to talk a little bit about our capabilities when it comes to our technology, and the reason why we're at the forefront of this kind of next revolution of really low power, tiny ML, if you will, devices that are very efficient with regards to processing data. And really, we offer a single chip that does this. But, I talked a lot about voice, because voice is so important from devices that we look at, if you think about wearable technology, and there's been a lot of talk about, the medical profession, or the growing mature Americans that need to be able to communicate if they're having a problem, with simple devices on their body or monitoring of their body. And so voice, you want to have these on for months on end, not a day or two where you have to charge them every night. These are wearable technologies. And so, those are of great benefit, and we see a lot of growth in those areas. But even within what we call acoustic events, think about glass break alarms and security devices, in our homes today. Those are getting more and more efficient. We can't just put one device in a single part of the room and monitor the entire system. We have to have devices in each and every room, and that's what's happening as well. And so, we're working with leaders in the industry to bring glass break detection, bring alarm detection, so think smoke and carbon monoxide alarm detection to bear as well. But we also move into other areas such as biomedical. So if you can imagine, we see a lot of devices that are constantly, that are monitoring, hopefully constantly the patients, if you will, and, for vitals and things like that. Think about our technology and its ability to be able to detect an anomaly like an AFib or something like that, always on. I mean, today we see devices where you put your fingers on them and they look and see if you're having an anomaly or some kind of a, heart arrhythmia. But that only happens randomly, and you never know when it's going to happen. And so, our ability to be able to look at that and monitor that and continually look at heart rate information to be able to detect an anomaly when it happens and alert the next stage or the system to be able to do something about that. It's pretty compelling. Smart grid technology with regards to, our ability to very low power be able to detect changes in power line, and so you can manage power lines. And this is applicable not only to the work we did with the government on that, but also in a commercial setting as well as in the home as well. And so, tremendous opportunity to save power for your home, be more efficient. Things like cap touch and vibration. So vibration is a huge growing demand outside of some of the other things I talked about, where not only do we want to monitor a machine, we want to monitor all of our machines in the factory and understand that first instance of when there's a problem going bad. It could be a bearing that goes bad. It could be, some other anomaly with regards to, the machine breaking down. And so we're able to detect those at the very first instance. And if you think about vibration in a maintenance worker, they typically would go up to a machine and either use hearing or use vibrational information to say, hey, we think we have a problem here. Well, technology such as ours and solid state technology is able to really do a deep analysis and understanding of those signals coming from the machine to make that determination as well. And so, we see a lot of opportunity there. And then, the last one is with regards to imaging, a growing industry for security and for many different aspects. But, there's a really strong capability there to be able to, a need to be able to go really low power so that a lot of these devices operate on battery power without having plug-in and persistent power. And so, think about the devices in your home that are doing monitoring, and how you can put those, in multiple rooms to monitor the video, if you will, but also in many security aspects also. And so, from Aspinity's perspective, we provide this single core. It's quite unique. It's called analog machine learning, and it provides the benefits of a lot of the other machine learning capabilities that you would find in the industry, but our technology is really based on this near zero power technology, which we call analog machine learning and RAMP. And so we're able to operate it just at really low powers and not miss any information as well. I think that's my summary. I'd be glad to take any questions or if you want me to drop back to any slides to go over as well. Appreciate it.
We have a few minutes left. If anyone has questions, you can put it in the chat. We can unmute you, or we can just talk about them as they come in. We'll give you a couple minutes to get them in there. Okay. I am not seeing anything coming in yet. Oh, Jack is requesting, Tom, if you could please show the contact slide again. I'm going to put this in the chat for everyone so you can easily copy that. And I'm going to take this second while we wait on other questions to potentially come in to say thanks for being with us today. From 11 to 12 today, we have our sponsors in the Technology Showcase, and I would encourage you to go there. DKey Communications will be presenting SD-WAN for your business. Jetstore will be presenting Big Data, AI ML using Superfast, OpenFlex, NVMeOF, and our other sponsors will be in their booths to connect with you and answer your questions with some networking in the networking room. And these are all available in SCED. And I see a question that came in while I was giving my spiel. So from Darren Roberts, we have, how sensitive is the voice activation to speaker gender/age?
So it's actually, we in this particular algorithm that we're running on our core, we actually are, it has no from an accuracy perspective, it picks up all speech. So it's been tested against, if I understand you, different languages and different age groups, if you will. And so it's actually just a purely an analog voice detection capability. And so it's pretty accurate. It picks up a lot of the, if not all of the voice, including someone, in speakers as well. So that is a challenge. I mean, if you are playing the TV, it will pick up speech, which it's supposed to do as well.
Thanks, Tom. Anybody else? I think that might be it. I will give a final reminder saying tomorrow at 9 a.m. we will hear from our keynote speakers at PNC presenting Building the AI-Powered Bank, Leveraging Advanced Analytics to Transform the Business of Banking. So those are my updates. Tom, this was a wonderful session. Thank you all for being here. Again, everyone, reminder to head over from 11 to 12 to the sponsors and the technology showcase. Lots of good things to see over there. And yes, we will look forward to seeing you the rest of the week. Thanks for registering for 2021 Beyond Big Data, and we'll talk to you all soon.
Thank you, everybody.
Thanks, Tom.